In today's lecture, we are going to talk about investment decision rules. We'll specifically looking at three: the net present value, internal rate of return, and the payback rule. Then we'll discuss how to choose between projects and capital rationing, that is, project selection with resource constraints. For most of the corporate decision making, the popular decision metric is net present value. To calculate the net present value, first we identify all the cash flows. Then we find the present value of all cash flows and sum them together. And if that sum is greater than 0, then we accept, otherwise we reject. So cash flows, present value of cash flows, and NPV and 0, whether it's greater than or less than 0. Sometimes alternative rules may give same answer, then we just follow these rules. Otherwise, if there's any conflict, we usually look at the NPV decision rule, give priority to NPV. Here's one example. The example is about a farm, and the project cost 250 million, and it's going to generate 35 million per year. It's a perpetuity. So we put it on the timeline. So initially we have 250 million. That's outflow. So that's time 0. And afterwards, for year 1, we have 35 million. Year 2, we have 35 million, and going on forever. So what is the present value of these cash flows? Then we need some kind of a discount rate. If we know the discount rate is R, then the present value is nothing but the 250 is 250 plus 35 over R. So if R is like 10%, then this would be a good investment. Okay. And let's look at what kind of R we have. Okay, so the net present value depends on the discount rate, as we mentioned. So if the discount rate is lower than 14% going this way, we have a net present value greater than 0, then we accept the project. And specifically, if the NPV is 10%, then if the discount rate is 10%, that gives a NPV of 100 million. So that's essentially 250 plus 35 over 10%. That gives us 350, 100 million. Okay, so that's NPV. And this is nothing but the perpetuity calculation. It's a perpetuity cash flow over the discount rate. And this chart is what we call a NPV profile. It is very important chart and used very frequently in the corporate world. The next rule is internal rate of return. And the rule says if it's greater than cost of capital, you accept, otherwise you reject. And most cases, the IRR rule will give the same answer as the NPV. In certain situations, it may deviate. So what is exactly the internal rate of return? The internal rate of return, if we look at this chart, it's where the NPV is 0. So this is the IRR. That's a rate that gives or makes a net present value to 0. So essentially, we can use a solver or some kind of tool to solve for the rate, and that give us a 0 NPV. So this is a crossover point. If the curve never cross over like this, then you don't have the internal rate of return. And sometimes you may have this type. Then you may have 2 or multiple internal rate of return. And sometimes you may cross from the bottom up. So there are all kinds of curves. We will look at some of those. And in the previous example, the IRR is 14%, whereas the cost of capital is 10%. That's the cost of capital, okay? And it is greater, so you accept the project. So in certain cases, the IRR rule may disagree with NPV. And mainly there are 3 scenarios. One is the investments are delayed. The other is the IRR does not exist. And there could be multiple IRRs. To just give you a simple scenario, if the project size doubled, the NPV will double. However, the IRR may stay the same. So it looks like you are indifferent from those 2 projects. However, based on the size of the cash flow or the value, you should accept one project against the other. So the IRR rule cannot be used to compare projects of different scales. Here's one example about the delayed investments. So the publisher, so this is a book deal. The publisher pays you $1 million upfront if you agree to write a book. And it may take you 3 years. And each year, you may give up other opportunities of $500,000 a year. Suppose your opportunity cost is 10%. So essentially, we need to first do the timeline. Okay. So we have $1 million upfront, and then so this is a positive, and then we kind of lost that opportunity. So this 0.5 million is the opportunity cost. So once we have these cash flows, if we know the R is 10%, we can calculate the present value of all cash flows, which give us a NPV. And with that R, we can calculate the IRR. Okay, the IRR, that's the rate to make this sum to 0. And we can either calculate the IRR using the calculator or use Excel to do the calculation. And with the calculator, the answer is 23. And you would say this is greater than the 10% cost of capital. However, you should accept the project. However, if we look at the NPV, it's not. NPV is a negative here. So in this case, we use the NPV rule and reject the project. The main reason here is the investments are delayed. If you look at here, investments are negative cash flows. So if the negative cash flows came later in time, that's called delayed investments. So in this case, the IRR rule may not work well. And we can illustrate this NPV across different discount rates. That's what we call the NPV profile. NPV profile. This kind of NPV profile, you see, IRR is a point that NPV may turn positive from that point onward. And sometimes we may have multiple IRRs. So in that case, we have sign changes in cash flows. So you may have negative, positive, positive, negative. This kind of sign changes and may give you some kind of NPV profile like this. Then the curve may cross the x-axis multiple times. So in this case, we have initially we have year 0, we get 550, so or 0.55 million, and then we lose negative 0.5 million, 0.5 million, and 0.5 million for the 3 years, and then year 4 we get 1 million. That's positive. So 1, 2, 3, and once we identify the cash flows, we can calculate the NPV, we can calculate IRRs. And in this case, because there are sign changes in the cash flows, the IRRs, we may end up with multiple. So that's a cash flow pattern, okay? And this is our NPV. And if we know the R, if 10%, we can calculate NPV, right? If we don't know R and try to force this to 0, then this is our IRR. So if you force this to 0, solve for one equation, solve for the R, that will be your internal rate of return. And in this case, you can see there are 2 crossover points. So there are 2 IRRs, and then we cannot use the rule of internal rate of return. And sometimes the IRR may not exist. As I mentioned, you may have some kind of curve like this. It never touches the x-axis if this is NPV. If it doesn't touch the discount rate horizontal axis, then if there's no crossover, how do you calculate IRR, right? So in that case, we could not calculate the internal rate of return. So something like this. So it never crosses the x-axis. The next rule is called a payback period rule. It is about how long you can recover your investment. How long we can recover the initial investment. So here we can say we can do a cumulative cash flow. Cumulative cash flows. So cumulate. Okay. So initially, and then add this to the previous cumulative cash flow. So this becomes 90, negative 90. And then add to this negative 90 becomes negative 30. And you compare these 2 cash flows because this is greater. So essentially, we say recover in 2 years. And that fraction, and some kind of fraction. That fraction is, if we assume this cash flow can be recovered evenly throughout this year, then it will be 30. Take the absolute value of this over 80, because the whole year we get 80, and somewhere around here, right? So it's essentially 30 divided by 80. So it's 0.375. So plus these 2 years. So it's a 2.375 years. So if we assume the cash flow distributed evenly across time, that's how long we recover the initial investment. So the rule is first identify the cash flows, second cumulative cash flows, third calculate the payback period. So these are the steps. Again, let's look at this again. So first we identify the cash flows and then cumulate. Once we have done the accumulation, and then we can calculate the payback period. So first find the big number and then find the fraction. Okay, the fraction is by taking the absolute value of the remaining cumulative cash flow to be recovered in the coming year, divided by the cash flow for that year. And there's a variation of the payback period, what we call a discounted payback. In that case, instead of using the raw cash flows, these are called raw cash flows. So in that case, we use the discounted cash flows. So this is discounted. So we discount these cash flows, okay, and then we accumulate. So the accumulation is the same. So if we call this step 1, you call this step 1.5, okay, and then this is step 2 and step 3. Step 1, 2, 3 are the same, except we have a middle step between 1 and 2. And in all cases, the discounted payback period should be longer because you are using smaller cash flows relative to the original cash flow. And there are pros and cons of payback period because payback period ignores. So as soon as you recover, so you recover all. So you recover all. Then if there are negative cash flows, for example, if there is a you have to clean up the mining site, for example, or if there are big lawsuits pending, then if there are big negative cash flows afterwards, it's not considered in the payback period. So that's so there are a few. For example, this is the one I discussed, and it's also not a good measure of profitability because it doesn't give you a dollar amount. However, because it's simple, so this is simple and easy to calculate, and it does give us a sense of the project's risk and liquidity. So it's used by a lot of small businesses and even for big businesses because this is simple to calculate. So they tend to use it together with NPV as well to judge the liquidity of the project. When we are choosing between projects, if they are mutually exclusive, we use NPV rule. And here's one example. So we have 4 projects here, 4 projects. So 1, 2, 3, 4. And if they are mutually exclusive projects, then we need to calculate the NPV and choose the one with the highest NPV. And if we look at the IRR, so this is greater. However, this is NPV is less. So when there is a conflict, we always choose NPV. And here the main difference is the scale of the project. Another problem with IRR is that it can be affected by changing the timing of the cash flows. even the scale is the same. So if the timing of the cash flows change, the IRR may change. Let's look at the previous slide again. Look at the coffee shop and the music store. And they have the same initial scale and the same horizon. However, the coffee shop has a lower IRR, but a higher NPV because of its higher growth rate. If you look at this coffee shop, so it has a higher growth rate relative to the music store. And when there are differences in risk, the IRR rule may not work. So IRR usually is attractive for a safe product that need not to be attractive for a riskier product. And if you look at the electronics store, the IRR is higher than those of the other investment opportunities. However, the NPV is the lowest. If we again look at this, the electronics store has the lowest NPV, and the IRR, if you calculate, it's among the highest. And here, the main reason is the cost, the risk of that project is much higher relative to others. So the higher cost of capital means a higher IRR is necessary to make the product attractive. Because the rule is the IRR need to be higher than the cost of capital. If you call it a weighted average cost of capital, we'll discuss that later in the semester. The last topic is about capital rationing. That means the company does not have enough resources to pursue all profitable projects. In that case, if the company has a certain budget, like 100 million in that case, then the company can either choose project 1, that gives 110 NPV, or the company can choose 2 and 3, so that's also 100 million, and that gives an NPV of 130. So what do we do? So we can also use the NPV, and in that case, this gives us 130, this combination. Alternatively, we can use profitability index. Profitability index is looking at the value created over the resource consumed. We call it a bang for the buck. So if it's greater than 1, if it's greater than 1, so it must be greater than 1 to take the project. So usually we look at, so this is a greater than 1. We look at the projects with a higher profitability index. And that's all for the decision rules. And there are, if once you are familiar with these 3 sets of rules, you can extend it further to other rules like modified internal rate of return. So in that sense, instead of using the raw cash flows, we'll move cash flows, the cash outflows, to the present value using a certain cost of capital, because the borrowing cost versus the investment return, these 2 rates could be different. So we use the borrowing cost to move the capital expenditures back to today's value, and move the cash inflows to a future value, and then we calculate rate of return. That is what we call a modified internal rate of return. And my preference would be like I first look at simple ones like the liquidity-based payback period. And then, of course, we also look at NPV. And there are a lot of scenarios, we don't have the right set of assumptions. Then the values we calculated may not be correct or may not be close to the reality. In that case, we may want to do different scenarios and estimate a range for the NPV instead of just one point. And thank you for watching this video. And if you have any comments, be sure to just comment below the video.